everyone, thanks for coming today. Today we're presenting a Databricks Delta Live Tables webcast. So just going over the agenda for today. First, I'll give you a quick introduction to Thorogood. Then I'll go into an overview of Delta Live Tables. Fernando will then take it over and he will do a Delta Live Tables demo, go through the key takeaways, and finally just a quick call to action about how you could get started with Delta Live Tables or get involved. So just starting off with who are we and what do we do? We at Thorogood are an independent and specialist data analytics company with a focus on data engineering, data science, and data visualization. We root our approach in understanding business goals and using the capabilities of technologies to meet these goals while the customers and business objectives remain at the forefront. We are a global company operating in offices throughout the world in London, Boston, Philadelphia, Singapore, Sao Paulo, and Bangalore. So just an example of some of the companies that we've worked with in the past. We have mainly operated within 4 verticals: banking, insurance, pharmaceuticals, and consumer goods. However, over the years, we have expanded our knowledge and also our experience while working outside of these verticals, accruing multiple skill sets and also just a wealth of knowledge. Below, I've listed some of the companies that we've worked with in the past, just to get a feel for some of the clients that we've had. As I stated in the first slide, Thorogood is an independent and technology agnostic consultancy firm, meaning that we are not specifically tied to a technology platform. So when it comes to customer implementation, we can be completely unbiased and provide a holistic perspective when it comes to the solution that we provide or the solution that we may propose to a customer. And below are just some of the partners that we have currently with Microsoft, Databricks, AWS, and GCP. And now to our next step in our agenda, I will go into a bit of an overview on Delta Live Tables, just to gather a quick understanding of what are Delta Live Tables, how do they operate, and how can they help us. So let's just start off with an example to demonstrate how Delta Live Tables are structured. Imagine that you need to travel from point A to point B, and you have 2 different ways or approaches of going about this. For the first approach, I could give you step-by-step instructions stating each turn that you must take in order to reach your destination from your original location. On a day with normal conditions, this would probably be an okay approach to take. However, if there are any roadblocks or traffic jams or a road was closed, this approach might not work the same way that you expected it to work. In those instances, you might want to know how to reach your destination in a more efficient path, or also your instructions simply might just fall short. A smarter way to do this might be to use a GPS, where you can instruct the GPS of your starting location and the destination you might hope to reach. The GPS will then pick or calculate the best route and might also calculate new routes depending on if you encounter problems or unexpected traffic arises. In this example, the GPS method characterizes declarative ETL approaches. And when using your own specific instructions, this describes the procedural approach to ETL. Delta Live Tables use the declarative approach, which allows the path to be optimized for efficiency and also sidestep specific roadblocks or potential roadblocks that may occur. By using declarative, Delta Live Tables basically optimizes our path from point A to point B. So in our example before, in our analogy, we had destinations and original locations. So this analogy could continue onto this slide where tables, for example, bronze tables might be our original location, and we might be wanting to get to our destination location being a gold table. Within Delta Live Tables, we can define tables and rules for their relationships. However, as discussed before, the ETL will define the best approach to process the data. As you can see below in these slides, we can build a graphical representation of the flow of the data and that the ETL will choose to take. So in this slide, you can see that we start at the bronze table being our origin location, and then we travel to one of the gold tables as our destination. However, we do not simply define how to get from the bronze table to whichever gold table chosen. The ETL process will define just a continuing instance of declarative ETL. So within the lakehouse architecture, as you saw on the previous screen, there are 3 different and separate tables being bronze, silver, and gold tables. When we ingest data from a cloud storage space or ingest data from alternate sources, this would be our bronze table. The table would consist of raw ingested data and also history data. Now we could commit some transformations on that data and move it to a silver table, which would contain filtered, cleaned, and augmented data that's in a set schema. After this, we could again do another transformation to transfer it to a gold table, which are comprised of business level aggregates, which then make it easy to do some type of visualization afterwards if that was in the plan for your data flow. So just a little bit more about Delta Live Tables. Delta Live Tables provide a platform to build and manage reliable data pipelines while simplifying the ETL process for an everyday user. They are easy to build and maintain the data pipelines. By building pipelines, all we need is a simple call to a PySpark function, which allows us to build pipelines within Delta Live Tables. We can also use automatic integrity checks and avoidance of data quality errors with predefined error policies. These predefined error policies will allow us to sidestep any roadblocks that might come within the pipeline and also allow us the ability to understand where those data quality errors are coming into play. Finally, we have deep visibility for monitoring and easy recovery. So as I said before, we can see when a Delta Live table were to fail. We can see the error that occurs when the Delta Live table fails and also have an easy path forward to fix the error that is occurring with the current Delta Live table. So one final thing to note about Delta Live tables, data ingestion workloads operate differently in Delta Live tables. Here on this slide, I have a usual example of how data ingestion workloads work without Delta Live tables. So in this example, we are ingesting data from a cloud source. We are ingesting that data into a raw data storage. Now we want to transfer all this data over to a process data storage. In order to do that, each time we update our raw data storage, we have to read and process the entire data set. And then we also would have to perform some transformations that we wanted to perform in order to get it to the process data storage. So again, this is in a usual data ingested workloads example. Now moving on to a Delta Live Tables ingestion workload example. This just benefits or shows off the benefits of efficiency with Delta. So we would ingest data from a cloud source as previously stated. However, in our raw data storage, we would then be partitioning our data within this storage container. This would allow us to only read and process the new data in our raw data storage, but also to keep the full data historic accuracy. When we read and process this data, we would then put it into the partition process data storage. By doing this, we cut down on the amount of rows that might need to be read and processed each time we update our raw data storage. For example, if we were only to update one row in our raw data storage, with Delta, we would only have to read and ingest that one row. However, in the alternate schema, you would have to read and ingest that entire raw data storage all over again. So I hope that gives you a little bit of understanding surrounding Delta Live Tables. I'm now going to pass it over to Fernando to give a really interesting use case and also a demo on Delta Live Tables.
Thank you, Melissa. Now let's go into the Delta Live Tables demo and let's see it in action using an interesting aviation use case. All right, so let's imagine that you are the manager of an airline. And this business usually rely heavily on planability regarding passengers, crew, fuel, and many other variables. One of the most important ones is, of course, time. And airlines pay significant fees to airports to use runways, gates, even just to stay on an airport grounds, then with big fee increments applied in case of delays. Therefore, estimating the flight arrival delay ahead and actively acting against it by balancing speed, fuel usage, and then delay fees can generate cost savings and greatly benefit the business. Estimating the arrival delay can also be useful for other time-sensitive applications, such as the delivery of consumer goods, for example, on a supply chain use case. The question is now how to estimate the arrival delay of a given flight or of a given consumer good delivery quickly, including data processing. For the airline business case, 1 minute can already be sensitive and can already generate costs. So you have to do it quickly enough that you can stream and process data in under a minute. So for this use case, we will use then machine learning, backed up with some features streamed down to the minute to predict flight arrival delays. In real life, the airline manager would have this data available, but to simulate that, we are using a data scraping algorithm. These features are extracted then by this data scraper algorithm from real flights taking place now in the US and streamed through an enrichment pipeline to finally be used to predict the arrival delay. Delta Live Tables is going to take this data and stream it down from raw state to process state, including feature processing and one-hot encoding to be ready for the machine learning model to be applied and predict the delays. The machine learning model was trained using FAA flight historical data from 2016, limiting our flight scope to the United States. And because we're using somewhat old data, our predictions might be a little off. They're still pretty good for a machine learning model. The features we're using today include scheduled departure time, scheduled arrival time, departure delay, total flight distance, carrier, and departure airport. And because of these last two, as you can see, they are categorical columns. So carrier is a defined operator, and the departure airport, they are categorical, meaning that they are not integers. And that's why we are one-hot encoding them. But I'll talk more about that during the demo. So here's an overview of our use case and of the demo I'll be presenting today. We'll start by creating the ML model and saving it using MLflow. Then we'll pick a current flight in the US and scrape its data. Then we'll define the data flow in Databricks and finally visualize it in the Delta Live Table section. And finally predict the flight arrival delay. I'll keep this visual up so you don't get lost in what I'm doing. So let's just jump right into it. Here's our first part then. So let's dive into the creation of the ML model. I'm here in Databricks. I have imported a couple of libraries, including MLflow, so we can save our model to then import it and use it as an end. Then we are importing our data set, as I said, is a 2016 FAA historical data set. And we are then trying to analyze the data, checking what are the columns that are available, just maybe to get some insight of that before we really model it in. We are using for the machine learning part a linear regression method, meaning that we have to have all numbers. And as I said, we cannot have categorical columns. And that is why we are one-hot encoding both origin and the carrier columns. Now we are training the model with the set and saving that to MLflow, which then we'll be able to import and use it as an endpoint towards the end of the use case. Now, let's try to pick a current flight across the US. For that, we can use any kind of website, but I'm using this one called Flight Radar 24. We can easily open it up. We can hover over the US and let's just dive in any part here. Let's go for Wyoming. There's a flight here. Click on that. Let's check if it has nice data. Yes, it does. So let's get this number and take notes of it. As we use this number to then feed it into our data scraping algorithm, scrape this data. We have this notebook here for the scraping. I have defined it already. We can come over and just input our flight code. It is UA1077 and easily run it up. We will start to scrape the data from another website every 40 seconds. So we have a continuous stream of data being deposited to this location in ADLS. Right, now that we have our data being streamed, it means that every 40 seconds, this table is being updated. So we have new data being placed there. So now how can we take this data and process it in an efficient way that we can only get the latest data and process it and feed it up to our prediction algorithm? And this is where we are defining our data flow. To define our data flow, it is as easy as setting Python tables. We come into a notebook and import a few libraries. This time we have to import DLT, so Delta Live Tables. And we can easily start by inserting the decorator, DLT.table, and start to define our table. So this is the raw current flight data, which points to my source location. So to the ADLS location where I'm streaming that, I am putting that current flight data on. So this is pointing to that. This is being updated. This will be updated every minute to do so. And then, as Melissa said, we can easily define our next table and just define a few rules from that. So we are reading that. our raw files and enriching that. So one hot encoding the two columns I said that were categorical. We are then one hot encoding them, so processing them live inside Delta Live Tables. So this means that you can use PySpark within Delta Live. So this is very powerful. And then we are returning our results here. So now that we have easily defined them, what happens if you, for example, try to run this code? It will error out. Why will it error out? Because, well, this is not a regular Python notebook. It's not a regular Python cell or Databricks cell. It is a DLT cell. So we have to go then to our workflows tab, Delta Live Tables tab, and create a new pipeline. Here we have a bunch of options, but let's start. So let's a pipeline name. So let's go for flight analysis. This is where I can point to my data flow notebook. Let's go there, Delta Live Tables webcast. Here is my notebook. So flight data flow. I can point to this notebook. And this, as I showed you, this previous notebook I showed you, will be the source for our data flow. We have a bunch of other configurations, but the most important one is the pipeline mode. So it can be either triggered or continuous. If it's triggered, it is a manual trigger. So every time you tell DLT to run, it will read the new data and transfer it over to your destination location. Or continuous, it will constantly read and transfer it over to the destination location. The destination location by itself, you can name it here. It can be something like one hot encoded, processed, and this will go to the Hive meta store. And then you can use that as an endpoint for Power BI or other applications, or even within Databricks, but I'll talk about that in a second. So after you hit create here, I have mine already created and running. We can go to visualize our DLT graph. And this is it. So this is running already for roughly an hour. It is running on continuous mode, as you see here, meaning that it is continuously taking the aircraft data stream I'm streaming from this notebook. It is processing it by one hot encoding every row that it gets and getting over to the destination location, meaning that one hot encoded current flight data. To visualize this and how is it looking, you can easily click here on the Metastore link. It will take us to a page. I have mine already loaded here. It takes a second to run. Okay, now you can have a look. How's your data looking? We can see here the schema and even some sample data of your data. So here there's a lot of data. As you see, there's the latest, probably the latest flight we are reading. All of the same departure time. So it's 6:28. It's still 2 minutes late as it looks. We can make a prediction over at our machine learning model. This is what we do now. Let's predict the arrival delay. For that, as I said, our data is already on our meta, in our Hive Metastore, which we can easily import using Databricks. So we are importing this table from the Hive Metastore, and we can start using it right away. I'm then importing my machine learning model using MLflow again, which we have saved there in the beginning of this demo, and then applying this model to our data. And then I'm getting a couple of results here. I'm not going to run this now. It takes a bit. It does get some prediction for us. And you can see here the power of the DLT, right? You can have data being streamed live from one location to the other and right away to your endpoint. And because it is, again, it is in Hive Metastore, it means that you can easily connect that to Power BI or to Databricks or to any other service that you like to use to see this data and to really get insights out of this. And you can even save, again, this predicted data to another table in the Hive Metastore and again, access it from another endpoint. So Power BI and whatnot, or whatever application you like the most. Great. So now let's head back into our presentation. Let's talk about some of the key takeaways from this. So I think that the main question that remains after you watch this demo might be a lot to take in, but the big question is, where can I use DLT and why would I switch from a regular data pipeline that I already have in place in my company? Well, I think that the answer to this question comes down to mainly 3 points. The first is that DLT's focus is on data streaming, meaning that it's most powerful in applications where it's needed to shorten the time between data collection and analysis. For our presented use case, we need estimates on the delays at least once a minute, because 1 minute can already cost money to the businesses. So if you take 2 minutes to process, that's already too much. You have to have the data ready by the minute. Other kinds of situations like profit calculations might not need as urgent insights for example, a consumer goods company, or even for airlines, or want to calculate profit. But the simplicity of Delta Live Tables can also be a deciding factor to apply DLT-based data movement, even in non-time sensitive use cases, because you have also the trigger methods. So related to that, DLT is very easy to implement, but it is very powerful in its results. So setting DLT tables is as easy as defining PySpark functions, as you see in the demo. And the data processed and moved by the pipelines are easily accessible in the Hive meta store, meaning that you can quickly connect it to Power BI and use the enriched data right away without the need to upload to Hive or connect to other services or the Databricks. And all of the computing and scaling happens automatically then within Databricks systems. So you only have to worry about sourcing the data and defining your silver, gold, bronze, or platinum tables, if you like, without having to worry about their size or the computing power needed to process those. So you can have small data, you can have big data. It doesn't matter. You just let Databricks handle the rest. You might still have questions even after that. So how can I use DLT, and is DLT really applicable to my use cases, to my company? Well, Thorogood can help you with that. And because we are specialized in advanced analytics, data science, machine learning, and more, and we come from a business-focused perspective and tailor a solution to best fit the needs of our clients, meaning that we can analyze your problem, we can analyze your use case and tell you if you can use DLT or not, and we can build pipelines for you. And I have here just a couple of examples of what we do currently. We do some exploratory analytics, MLOps and DevOps, industrialization, analytics architectures, data democratization, analytics empowerment, multi-cloud and flexibility, and analytics strategies. All that to say that we can help you develop your pipelines. We can help you develop your data streaming or data ingestion issues and problems and challenges. We can help you with that. So please feel free to reach us out. I leave you here with our emails and our LinkedIns. Feel free to contact us regarding DLT questions, our questions about the webcast, about anything you saw in this presentation, and also on how we can help you. We'll stay available through all of our links. Thank you for your time again, and have a nice day.